Hello everyone, so here are your notes for 1.2, measuring and constructing segments. Let us first start off with the segment addition postulate. So basically what we're going to be doing here is we're going to be adding segments together, but in a very specific way. So if point B, so if B is between points A and C, then here's what we have. First of all, we have a picture that looks like so. I have a segment AC. It goes from A all the way to C. And point B is somewhere on that segment in between A and C. Then what we can do is this. We can take the length for AB and I can add it together with the length for BC. And what happens when I add these two lengths together is I will get now the entire segment from A all the way to C. And this is the basic idea of the segment addition postulate. If you have an entire segment, we can take the two parts of the segment, add it together to get the entire one. All right, so let's go ahead and let's take a look at an example. So it says that point R is between points Q and P on segment QP. If QR is 5 and PR is 9, find QP. Okay, so first thing that we notice is that we are working with a segment and we're going to call it QP. So let's go and let's draw that in. A segment has two endpoints. The names for the endpoints are the same as the ones we use to name the segment itself. So one point is going to be called Q. The other point is going to be called P. Now, it also says that point R is somewhere between these 2 points. Where I'm going to put it, maybe let's say right about here. It's not going to be exactly in the middle because the problem does not tell us that R needs to go in the middle or R is halfway between Q and P. So that's why I'm going to go ahead and put R a little bit off to the left side. All right, and then from there, now we can label this picture with the information given to us. They told us that QR is 5. So I'm going to go ahead and label from Q to R is 5. They also tell us that PR is 9. So from P to R, this length right here is 9. And they want us to find the length of QP. In other words, the entire segment or entire length here. This is what we're looking for. So using the segment addition postulate, we can go ahead and write the two parts of the entire segment. So I have QR, which is one part. I can add that together with PR or RP, however you want to say it. It's the same thing. This is going to be equal to the entire segment from beginning to end, which is QP. From here, all we need to do now is substitute in. QR is 5 plus PR, which is 9, and this will be equal to QP. Now, I realize that most of you will be able to add 5 plus 9 very quickly and set it equal to the correct number. However, we are going to continue to leave QP on the right side so that we know what segment or what part it is that we are solving for. So let's go ahead and let's finish this up. 5 plus 9 is going to be 14. And that is how long QP is. All right, here is another example. So we are still working with a segment QP. And the point somewhere in between is still going to be R. Based on the given information here, though, it says if QR is 11 and QP is 23, then we now need to find PR. Okay, so let's go ahead and take a moment and label our picture one more time. QR, they give to us as 11. So let me go ahead and label QR as 11. Then they tell us QP is 23. From Q all the way over to P, this is 23 units long. The last part that they want us to find is PR. So from P all the way over to R, this is our question mark. This is what we are solving for. But here's the thing, even though we are solving for PR, the equation that we're going to write is still exactly the same because QR added together with PR will give us the entire length, QP. That doesn't change. So QR plus PR is going to be equal to the entire segment, which is QP. Now we just substitute in for whatever we're given. QR is 11 plus, I don't know what PR is. I'm going to go ahead and just leave it as PR. This is the variable that we are solving for. And this will be equal to QP, which I can substitute for 23. All right. Because PR is my variable, I need to go ahead and I need to isolate it. I need to get rid of any numbers on the same side. I see that we have a positive 11, which tells me I need to go ahead and subtract 11 on both sides. 11 minus 11 becomes 0. I am left with PR on the left side is equal to 23 minus 11 is going to be 12. So PR is 12 units long. All right, go ahead and pause the video here and see if you can give both of these problems a try. All right, go ahead and check over your answers. Again, for both of these problems, the segment addition postulate equation is going to be exactly the same. It just depends on where or what information is given and where you substitute. All right, let's go ahead and let's give one more a try. So in this example, it says given the information below and point U is between point T and point B. They need us to find X and TU. All right, so first thing that we need to take care of is our picture. It says that point U is between point T and point B. So let's begin again with a segment. And because point U is in between, we know then that point U is going to go somewhere in the middle or somewhere on the inside. And then we will have point B, or actually let's call that point T. Point T and point B on the endpoints here. Okay, now as always, we take each piece of information given and label it. So it says TU is 3x. So here is TU. Going to label that with 3x. They also tell us UB is 5x plus 1. So UB is the second part of this segment, and it is 5x plus 1. The last piece of information provided for us is that TB is 17. TB is the entire segment. So I'm going to go ahead and mark it like so and say that that's 17. Again, one more time, using segment addition postulate, we take TU, add it together with UB, because these are the two parts of the segment, and it should be equal to the length of the entire segment itself. So, TU plus UB is equal to TB. Now let's go ahead and substitute in. TU is 3x, and I'm adding. Because I'm substituting in an algebraic expression, I'm going to use these parentheses just to play it on the safe side. 5x plus 1 is equal to TB. Substituting that in is 17. So in order to solve for x, what we need to do now is we need to, solve. First thing that I notice is that I have my x's or my variables on the same side of the equation. So if they're on the same side, we can go ahead and we can combine these. Positive 3x and a positive 5x gives us positive 8x. And I haven't done anything to the plus 1, so I'm going to go ahead and include that on the left side. 8x plus 1 is equal to 17. Continuing to solve for x, we go ahead and we will subtract 1 on both sides because we're trying to isolate the x. 8x comes on down, and 1 minus 1 is 0, and this is equal to 17 minus 1 is 16. Last and final step, we need to go ahead and divide on both sides by 8. And I'm going to finish up over here. 8 divided by 8 becomes 1, and so we're just left with 1x, or just x, and 16 divided by 8 is 2. All right, so that is one of our answers. It's set to solve for x. But keep in mind that in the problem, it also wants us to find TU. So TU is here, and it was given to us that TU is 3x. So let me write that equation down. TU is equal to 3x. And now what we're going to do is we are going to substitute in. So TU is equal to 3 times 2, because that's what x was. And so at the end of the day, we get that TU is equal to 6 units. All right, go ahead and pause the video here and see if you can give this one a try on your own. All right, go ahead and check over your answers. Again, we use the exact same equation, TU plus UB is equal to TB. Making sure that you substitute in appropriately, TU is 2x plus 6, UB is just a simple x. Again, combining like terms because they are, or my x's are on the same side of the equation, on the same side of the equal sign. When we finished solving, we found that x is equal to 6, but again, the problem is asking us to find UB this time. So we take a look at UB. Oh, UB is x. So when I substitute in 6 for x, we find that, well, UB is also 6 units long. All right. So let's go ahead and let's go over just a few quick definitions. I'm going to get rid of this axiom postulate because we're not worried about that right now. Instead, taking a very quick look at coordinates. Again, these coordinates tell us where points are located. As a reminder, coordinates look a little something like this. They look like x, comma, y. The x coordinate here tells us to move left or right. And by how many units? So that would depend on what number is there in place of x. And then the y coordinate tells us to move up or down, depending on what number y is as well. All right, now one new word that we are going to add into our vocabulary is this word congruent. Now, congruent, you might see it as a symbol. It is written with an equal sign and a little squiggly on top. Technically, it's called a tilde. Here's what it means. Congruent means that your objects are the same size and same shape. So for example, if I have two line segments, let's call this line segment AB. Let's go ahead and let's draw in another line segment. Let's call this CD. Now, because these are both line segments, I already know that these two line segments are the same shape. In order for them to be the same size, they would have to be equal in length. In other words, how long they are have to be the same. In a picture, you might see them marked with these tick marks, okay? These tick marks right here mean congruent. So even if it doesn't tell you in the problem, but you see these markings, you are allowed to assume that the segments are congruent. Alrighty, let's go ahead and let's quickly take a look at an example. So in this example, it's asking us to determine whether segment JK and segment LM are congruent. Okay, so here is segment JK and here is segment LM. Because these two segments are nicely placed on the coordinate plane, one is exactly horizontal and one is exactly vertical, we can go ahead and we can just quickly count the number of units. So for JK, I can start at J, 1, 2, 3, 4, 5. So JK is 5 units long. Let me go ahead and write that off to the side here. All right, and then LM, let's start at L and count 1, 2, 3, 4. This is also 5 units. All right, and then so if we are determining whether or not these are congruent, then we need to say yes or no, but we also need to explain. So, yes, segment LM and segment JK are congruent because they are the same length. Okay. And another way you might see this written is you might see it as segment LM is congruent to segment JK. So that is another technically statement that you can write. It is completely symbolic, but we read it as segment LM is congruent to segment JK. All right, so go ahead and pause the video here, graph these coordinates, and see if you can give this one a try on your own. Alrighty, go ahead and double check over your answers. The first thing you want to double check to make sure is that your coordinates are properly plotted down. If they're not, then when you count them, you might not get the correct length, the correct distance between the 2 points. But after doing that, we go ahead and we quickly count the units, number of units for AB. Same thing for CD, and we find that they're both equal. And so segment AB is congruent to segment CD. And as always, we provide a reason because segment AB and segment CD are the same length. All right, so that is it for your notes for 1.2. Thank you very much for watching.